In this question, it is given that 1 calorie of heat flowing through a rod of iron per second. When the rod is cut down to 4 pieces, then what will be the heat flowing through each piece per second having same differential temperature? So just remember one thing over here. In this question, they are given the word as differential temperature. That means difference in temperature with respect to distance. They are talking about dt by dx. They are not talking about delta t. It's not difference in temperature, it is differential temperature. Means they are talking about dt by dx. That means temperature gradient. So over here they would like to say that we are maintaining a constant temperature gradient, and then what about the value of heat flow? So we can just consider a rod over here, and we are dividing this one into 4 equal parts. Let's say one part is something like this. So definitely length of this one is going to change. Let's say the length of this one is going to be L divided by 4, and area will remain same. And our aim is to find out what about the value of rate of flow of heat energy. So we can write rate of flow of heat energy dq by dt is equal to Ka delta T divided by L. So over here, this difference in temperature with respect to distance, they are keeping it as constant. That means this we can take it as dt divided by dx, which we call it as differential temperature or temperature gradient. So over here, temperature gradient is constant. So you should not think that the length is becomes L by 4 and maintaining the same temperature difference across this one. It's not like that. The differential temperature is same. That means dt by dx is a constant, and area is also constant, and K same material, so K is also constant. So initial heat flow was 1 kilocalorie per second. So still it will be 1 kilocalorie per second because we are providing the same differential temperature or temperature gradient, same area of cross section and same K.